Good morning, class 10th. This is chapter light, reflection and refraction. We are done with the ray diagrams rules, and here we are going to draw the images from concave mirror and convex mirror. So very first of all, we are drawing the images through concave mirror. The concave mirror have a cave inside it. It means it is something like this. It has a cave inside it, that's why we call it a concave mirror. This is its representation. Now the very first object image is when object is at infinity, then the image position will be at focus, and the nature of image will be real and inverted. Real images वो होती हैं that lie on the same side as of the object. So and the size is point sized or highly diminished. Here we have the object as AB, that is at infinity. So the light rays come like this, and we know the rule that when a parallel ray comes and strikes to the mirror, it goes back through the focus. Same as with this ray, if it is coming parallel to the principal axis, then it will strike to the mirror and reverse back through focus. So in this case, the image will be formed at focus. It will be point sized and highly diminished because these two rays meet at this point, and this is just a point size thing, right? So this is the position of the image. Okay, now here this is our second case when object is beyond C, यानी कि जब C से पीछे हो. C is center of curvature, F is focus, P is principal, and this is principal axis. So the image position will be between F and C, between focus and center of curvature. Okay, the nature of image will be real and inverted. Inverted means उल्टी बनेगी. रियल यानी कि सेम साइड पे बनेगी जहाँ पर ऑब्जेक्ट है. ऑपोजिट साइड होगी दिस वन, द राइट हैंड साइड ऑफ द मिरर, बट द इमेज विल फॉर्म ऑन द लेफ्ट हैंड साइड एज सेम एज ऑफ द ऑब्जेक्ट. So here we have the object as AB. This is AB beyond C. So the very first ray will go parallel to the principal axis, and it strikes to the mirror and reverse back through the focus here. Now we know the another rule of ray diagram as well, that when a ray moves through the center of curvature, after striking striking to the mirror, it reverses back through the center of curvature. So this is the ray of that is traveling through center of curvature, that will reverse back to center of curvature. So this is the point at which they both strikes, and this is the point where the image will be formed, that is A dash and B dash. This is real and inverted. The size will be diminished, यानी कि जो actual object का size है उससे छोटी बनेगी. So that's why it is diminished in size. The third case is when object is at C. C is center of curvature. So image position will be at center of curvature. Nature of image will be right and inverted. Size will be same as that of object. Okay, so what happens? Same, the very first rule, the ray will go parallel to the principal axis. After striking back, it will move through focus, and the image and the ray that goes through focus will strike at mirror, will go back to the parallel of the principal axis. Now this is the point where they both strikes to each other, where they both join each other. Now we will mark this point as image position, that is A dash and B dash. Now this is the fourth point where when object is placed between focus and center of curvature. Object is placed between focus and center of curvature. The image position will be beyond C. The nature of image will be real and inverted. साइज विल बी enlarged, यानी कि एक्चुअल ऑब्जेक्ट के साइज से वो काफ़ी बड़ी बनेगी इमेज. ओके, सो सी here is our center of curvature, this is our focus. We have to take equal distance between these points. This is just the radius and this is center of curvature. This is radius, this is half of radius. F is the focal length, that is half of the radius, and here is the object, that is AB. So very first rule, the ray that goes parallel after striking back, it will move through focus and goes to this direction. Now the another rule of the ray diagram is when a ray moves through center of curvature, it after striking back to the mirror, it reverts back through the center of curvature. So this is the point where they both joins each other, where they both strikes, and here is the image formation, that is A dash and B dash after joining each other. Now moving to our fifth case, that is this one, when object is placed at F, that is focus. What will be the image position? The image position will be at infinity. Nature of image is real and inverted. Size will be highly enlarged, यानी कि काफ़ी ज़्यादा बड़ी बनेगी, क्योंकि इन्फिनिटी पर बनेगी और इन्फिनिटी पर हम लोग कोई चेक नहीं कर पाते कि कितना साइज़ आया है. सो दैट्स वाई हम उसको अज्यूम करते हैं कि वो काफ़ी बड़े साइज़ की बनी है. सो हियर एट फोकस देयर इज़ द ऑब्जेक्ट. So let's apply the very first rule. When the ray travels parallel to the principal axis after striking, it reverses back through focus. And the another rule, that is when a ray moves through center of curvature after striking, it will revert back through the center of curvature. So here the image will be formed at infinity, and that will be highly enlarged. Now the sixth case is when object is between P and F. P is pole and F is focus. So image position will be behind the mirror. This is the only case in concave mirror that the image position will be behind the mirror. Okay, so what happens? The nature of the image, the nature will be virtual and erect. इसमें सारी चीज़ें चेंज हो जाएंगी, क्योंकि जो इमेज पोजीशन है वही चेंज हो गई है. यहाँ पर अब इमेज जो होगी वो रियल की बजाय वर्चुअल बनेगी. वर्चुअल इमेजेस वो होती हैं जो ऑब्जेक्ट के ऑपोजिट साइड पे बनती हैं, यानी कि मिरर की बैक साइड पर बनती हैं. दैट आर वर्चुअल इमेजेस. दिस विल बी इरेक्ट, यानी कि बिल्कुल सीधी होगी, जैसे ऑब्जेक्ट है सीधा वैसे. एंड साइज विल बी इनलार्ज्ड, साइज इसका काफ़ी बड़ा होगा. So here is the object in between focus and pole. This is AB as object. So we know the rule that angle of incident will always equal to angle of reflection. This is the actual ray, and we are assuming this as an imaginary ray which will be took through this reflected ray. And the second rule of ray diagram is when a ray moves through center of curvature, after striking back, it reverses through the center of curvature. But here too we will take it as an imaginary ray, and the point where they both joins each other will be the image position, that is A dash and B dash. And in this case it is at the right hand side, it means behind the mirror. And the image nature of image will be virtual and erect. Now moving next to the ray diagram formed by convex mirror. These were the cases that took place in concave mirror. Now these are the cases which will take place in convex mirror. In convex mirror there are only two cases. First is when object is placed at infinity, the image position will be at focus. The nature of image is virtual and erect. Size will be point sized. See how in this the image will always form behind the mirror. Okay, we have to imagine the rays just like we did it in the last case of concave mirror. So here the object is at infinity, that is AB. The rays come parallel to the principal axis and they will get diverged, but we will take the imaginary ray and pass it through the focus. This will be the image position, that will be A dash and B dash, as it is point size, so that's why we haven't mentioned A dash and B dash. Okay, so this will be the first case in convex mirror. Now here is the second one. When object is placed between pole and infinity, image position will be between P and F. Nature of image will be virtual and erect. The size will be diminished, यानी कि actual size के object के actual size से वो काफ़ी छोटा बनेगा. So here is the object, that is AB. Very first rule, when the ray travels parallel to the principal axis, it will after striking to the mirror, it will diverge, and the imaginary, we will take the imaginary ray through the focus as this one. And the second rule we will take is this, that we will move this ray through center of curvature, but in this case the center of curvature is at the right hand side, so we have to took the imaginary ray as the original ray. Okay, so here this is the point where these two rays join each other, and this will be the position of image, that is A dash and B dash. Here a full length image of a tall building or a tree can be seen in a small convex mirror. We can see that in a small convex mirror. और कभी कभी ऐसा भी होता है कि बिल्डिंग्स के आगे काफ़ी छोटे छोटे कन्वेक्स मिरर्स लगे रहते हैं, सो वहाँ पर काफ़ी जो बड़ी बड़ी बिल्डिंग्स होती हैं हम उनको देख पाते हैं ईजिली. So those are convex mirrors. So these two were the cases of convex mirrors, and the earlier 6 were the cases of concave mirror. Now here we have a mirror formula, that is 1 upon V plus 1 upon U is equals to 1 upon F, where V is image distance, U is object distance, and F is the focal length. This formula is gonna use in this chapter. Now here we have a magnification of spherical mirror, that is M is equals to height of image upon height of object, that is M is equals to HI and HO. HI is height of image and HO is height of object. Also M is equals to minus V upon U. If M is negative, it means the magnification is in negative, the image is real, it means the image will form on the left hand side, and or in other words we can say that the image will form on the side of the object. If M is positive, the image is virtual, so it means the image will form on the right hand side or the opposite side of the object. Here the reflection term finished. Now in the next class we will start refraction.